What if the universe's first light didn't come from stars at all, but from something far more exotic? The James Webb Space Telescope has spotted ancient light sources from a time when stars shouldn't even exist yet. Now, scientists are scrambling to explain what could be glowing in a universe just 100 million years old. Could it be that black holes, yes, black holes, were the first to shine? In this video, we're diving into the new JWST data, a radical theory about primordial black holes, and what this all means for the beginning of everything. Something strange is coming from the farthest edges of the cosmos, light that simply shouldn't be there. Using its powerful near-infrared camera, JWST peered into the ancient universe and uncovered 9 incredibly distant light sources. These weren't just faint glimmers, either. They shone with strong ultraviolet blue light, exactly the kind of light we'd expect from the universe's first generation of massive stars. But here's the twist. The light is coming from a time before stars should have formed at all. The redshift values of these sources, 6 at redshift 17 and 3 at redshift 25, mean they existed when the universe was just 200 million to 100 million years old. That's far beyond what our models currently accept as the earliest window for star formation. So far, the highest confirmed redshift for a galaxy is 14, representing about 300 million years after the Big Bang. If these new candidates truly lie beyond that range, it means we're staring at something more ancient than any star or galaxy we've ever seen. Pablo Perez Gonzalez and his team at the Center for Astrobiology in Madrid found these objects after over 100 hours of imaging across 2 JWST surveys. They filtered through more than 80,000 objects, identifying just 9 that matched this bizarre early light profile. The team is confident these candidates are among the most distant and possibly the most unusual objects ever detected. And if confirmed, they could force cosmologists to tear up the script on how the early universe behaved. So why is this such a big deal? Because galaxy formation isn't instant. You need dark matter structures, cooling gas, and time. Without these, gravity can't compress material enough to spark star formation. According to our current understanding, the gas in the early universe was still too hot, too scattered, and too unstable to form stars in under 200 million years. Which brings us to the next big question. If these glowing sources aren't stars, then what are they? To solve this cosmic riddle, some scientists are turning to a bold and exotic idea. Primordial black holes, these hypothetical objects may have formed just seconds after the Big Bang, bypassing the usual star collapse process. They wouldn't be born from dying stars like modern black holes, but instead from the turbulent density fluctuations in the fabric of space-time itself, during or immediately after the universe's inflationary expansion. Andrea Ferrara, an astrophysicist at the Superior Normal School in Pisa, is one of the leading voices supporting this theory. He believes that these ancient black holes could have begun life no larger than an atom. But given enough time and access to gas, they could grow into monsters, 10,000 times more massive than our sun. And while black holes are famous for swallowing light, they're also capable of producing it. As gas spirals into their gravitational grip, it heats up to extreme temperatures, emitting powerful radiation. From a distance, this could look uncannily like a young, blue star. This idea isn't just theoretical hand-waving. Primordial black holes would explain why these sources appear point-like in some of JWST's images. Too small to be early galaxies, but still incredibly bright. Perez Gonzalez's team measured the sizes of the new light sources. Around 30% of them seem to match what we'd expect from compact black hole systems. Others appear more extended, which might still suggest starlight, or perhaps a mix of both. If primordial black holes were indeed the first luminous objects, they could also solve another cosmic puzzle: the presence of supermassive black holes just a few 100 million years after the Big Bang. Their origins have long baffled astronomers. How could something so massive form so fast? The primordial black hole hypothesis offers a compelling shortcut. These cosmic seeds may have simply been around since the very beginning, growing steadily over time until they reached monstrous proportions. It's a mind-bending idea, but it's gaining traction because nothing else fits the data this neatly. And as wild as it sounds, the possibility that black holes lit up the universe before stars did is now being taken seriously. The more JWST looks, the more it challenges our entire timeline of cosmic evolution. Until recently, astronomers believed they had a reasonably good handle on how galaxies formed. The basic model goes like this. Dark matter clumps together first, forming gravitational wells. Then, gas is pulled into those wells, cools, and eventually condenses into stars and galaxies. This process takes time, hundreds of millions of years at least. So when JWST starts finding massive galaxies and bright light sources just 100 million years after the Big Bang, it raises red flags. Alison Kirkpatrick, a galaxy evolution specialist at the University of Kansas, sums it up. JWST is finding too massive galaxies too early in the universe. The discovery of these 9 ancient light sources adds fuel to that fire. They push the boundaries of what we think is even possible, given the known physics of early cosmic structure. What makes this discovery even trickier is how difficult it is to interpret. These candidates were found using imaging data. To confirm their distance and nature, astronomers need spectroscopy, a method that breaks down the light into its component wavelengths. This tells us the exact redshift and gives clues about the object's composition. Without this data, there's always the chance we're being fooled by a closer, less exotic source that just happens to look ancient. But if spectroscopy confirms these are indeed ultra-distant objects, we'll have to reckon with a serious contradiction between observation and theory. Cosmology would need a major update, possibly involving new physics or unseen forces at play during the cosmic dawn. And there's one more twist. Primordial black holes, if real, would leave their fingerprints not just in visible light, but also in the cosmic microwave background, the afterglow of the Big Bang. But today, SCMB maps are still too blurry to detect the tiny distortions these objects might cause. Future missions with sharper instruments may provide the missing evidence to confirm or deny their existence. We're standing at a moment where observation is leaping ahead of theory, and what JWST is showing us could signal the beginning of a whole new era in our understanding of the universe. We may be closer than ever to rewriting the origin story of the universe. Whether these strange lights are ancient stars, unknown galaxies, or black holes born seconds after the Big Bang, one thing is clear. JWST is forcing us to question what we thought was settled science. If primordial black holes really were the first to light up the cosmos, we're going to need a whole new playbook for how everything began. Thanks for watching. If you want to explore the universe's secrets even deeper, be sure to like, share, and subscribe.